In this video, we're going to talk about percent composition. We'll start with the definition of percent composition. So percent composition is a mass percentage. So we're talking about mass, not how many atoms there are, but mass. Mass percentage, and it's the mass of an element, a specific element usually, in the entire compound. Or in an entire sample. So if you think about what calculations goes on in a percentage, we usually take something and divide it by the total. So there is an equation for this. Whenever we calculate the percentage, we always take whatever we're interested in divided by the total mass. So the mass in this case is the mass of the element divided by the total mass of the sample. And because it's a percentage, we multiply by 100%. So for example, if you're interested in the percent composition of carbon in CO2, one way of doing that is to say, what if I have a mole of carbon dioxide? What if I have a mole of carbon dioxide? Right. So if you have a mole of carbon dioxide, and you take the mass of that, that's called the molar mass. So the molar mass of carbon dioxide is 12 for carbon plus 2 times 16 for oxygen. That's 44. Right, so that's your total. And then you go on the top. You're going to write down the mass of carbon inside carbon dioxide. And because there's only one carbon, it only takes up 12 grams. So when we're writing this, it means that carbon takes up 12 grams out of 44 grams. And that is 27.7%. So if you want to convert back to a decimal, right, as a decimal, it is, if you just want to leave it as a decimal, you would not multiply that with percentage, with 100%. So you want to leave it as a decimal, it's just 0.277. So usually when you type this math into the calculator, you don't type into percentage, you type in a decimal when you have to use it. Okay. So let's take a look at another example. This is in the textbook, page 201, question number 1. It says a sample of a compound is analyzed and found to contain 0.90 grams of calcium and 1.60 grams of chlorine. The sample has a mass of 2.50. Find the percent composition of the compound. When they say find a percent composition of the compound, they mean all the elements in the compound. So here we have calcium, you have chlorine, and then they told you the mass of calcium and the mass of chlorine, and they even told you that the sample has a mass of 2.5 grams. So this mass here is our total. Okay. So the second thing is that you may notice that these are not molar mass, right? Like, so you look at calcium, 0.90 grams, that's certainly not the molar mass of 0.90 grams, of calcium, because calcium's molar mass of would be 40. And this is not chlorine's molar mass, because chlorine's molar mass is 35.453 grams per mole. But that's okay, right? Because they didn't tell us the formula. They told us that the total is 2.5, and then out of 2.5, so out of 2.5 grams, 0.0 0.90 of it is made of calcium. And then out of 2.5 grams, because that's the total, they told us that 1.6 of it is chlorine. So we don't necessarily need the chemical formula in this case, and we don't necessarily need to use the molar mass always. As long as we have a sample, they told us the total mass of the sample, they told us the mass of each element, we can go ahead and calculate how much mass each of these elements take up in the entire sample. So if I do that, 0.9 divided by 2.5, the decimal is 0.36. So 0.36 times 100, that's 36%. So, and then if you take 1.60 divided by 2.5 times 100, that's 64%. And that makes sense, because the total between the two should add up to 100%. So in here, in this step here, instead of doing 1.6 divided by 2.5, once you found that the first element is 36%, and there's only two elements, you can do percent chlorine is equal to 100% minus 63%. That is, 36%. That is 64%. So that's another way of doing it. But remember what these numbers mean. This means that 36% of the sample mass is from calcium. Right? And then 64% of the sample's mass is from chlorine. So that's what those numbers mean. It doesn't mean 36% of the atoms, because these elements, calcium and chlorine, each atom of calcium, each atom of chlorine have very different masses, but it's 36% of the total mass. Let's take a look at another example. So this is on page 204, number 8. It says a mining company wishes to extract manganese metal from MnO2, pyrolusite ore. What is the percentage composition of pyrolusite ore? B, use your answer from part A to calculate the mass of pure manganese that can be extracted from 250 kilograms of pyrolusite. So in doing A, again, percent composition of the ore means they want to know the percent composition of each of these elements. So we have percent Mn and percent oxygen. They didn't tell us how much the sample is, but that's okay. If they didn't tell us how much it is, or how many grams are there, let's just assume that there's 1 mole. Okay. So if we assume 1 mole, then we can use the molar mass. So if we're talking about manganese, the molar mass of manganese is 54.9380, and there's only one of it, so 54.980 grams out of manganese 4 oxide, so 9380. Plus, there are 2 oxygens, so it's 2 times 16. That gives us 86.938. So that's the total mass that we can use. 86.938 grams. Times that by 100%, and that gives us 63.2%, which means that oxygen is the remaining, so we can take 100% minus 63.2%. That would give us 36.8%. So 36.8% of the mass is made up of oxygen, and then 63.2% of the mass is made up of manganese. And in question B, they ask us, what if you have 250 grams of the entire thing? So now we know the total. That total is 250 grams. What do you have 250 kilograms? How much of that comes from manganese only? Because they talk about pure manganese, right? So from question A, we know that manganese takes up 63.2% of the total mass. Okay. So what I mean exactly by total mass, and the beauty of this percent composition thing is it doesn't matter how much sample you have, like whether you have 250 grams or 1 gram, or in the in A before we pretended we have 86.938 grams, which happens to be a mole. It doesn't have whether if you have 1 ton or 2,000 grams or 0.1 gram. Doesn't matter how much mass you have. When you calculate percent composition, manganese out of the total mass would always take up 63.2%. So if you have 1 gram, it will be 63.2% of 1 gram. If you have 250 grams, it would be 63.2% of 250 grams. So this percentage always stays the same. It's always 63.2% of the total, regardless of what the total is. So in this case, they're saying that the total is 250 kilograms. So we know that it takes up 63.2% of 250 kilograms. And in math, the word of always means to multiply. So we can change this to a multiplication. And when we write that, it means 63.2% of 250 grams comes from manganese. So when I write this, again, it means that manganese, the mass of manganese, so I should really write mass of manganese. Mass of manganese is always 63.2% of the total mass. So in this case, 63.2% of 250 kilograms comes from manganese only. And if we were to continue this, your calculator sometimes have a percentage button, but I wouldn't depend on it. So I'll just convert this back to a decimal, which is 0.632 times 250 kilograms equals 158 kilograms. So again, what this means is that 158 kilograms of the sample, of the 250 kilogram sample, comes from manganese only. Okay, so you can sort of figure out that oxygen would make up the rest of the 92 grams. Okay, if 158 grams comes from manganese, then oxygen would be the rest of it, which is 92 grams. So here we have another question about percent composition. It's really just kind of like the last question, except they didn't give you as many steps. So this comes from page 205, question number 3. It says indigo C16H10N2O2 is the common name for the dye that gives blue jeans the characteristic color. Calculate the mass of oxygen in 25 grams of indigo. So what you have to realize is that when I say 25 grams of indigo, that is their total mass of the sample. Okay. But they only want oxygen. Okay. So this really we can do this in one step, or we can do it in 2 steps. So actually I'll show you in 2 steps first. So first, they want the mass of oxygen. But if we can calculate percent oxygen, then that would tell us that, again, no matter what the total is, the percent of oxygen is always the same. So let's use percent of oxygen. Okay. They gave us a chemical formula, so that means that we can use molar mass. If they gave you a formula, then you can use molar mass to figure out the percent. To calculate percent oxygen. So the entire formula has 16 carbon. So 16 carbon plus 10 hydrogens plus 2 nitrogens plus 2 oxygens. And that's the molar mass of the compound. Since we're only interested in oxygen, we'll take the mass of the oxygen only. So now, when we do this, this fraction, or this percentage, would give us then that percent is equal to 12.2%. So that means 12.2% of the total mass comes from oxygen. So now that we know it's 12.2%, we can say that 12.2% of 25.0 comes from oxygen, the mass that comes from oxygen. Again, the word of in math means we multiply. So that's the equation that we have. We're going to change it back to decimals. So 0.122 times 25.0 grams of the mass is oxygen. So that means this mass must be 3.05 grams. So what did we just calculate? We just calculated that the mass of oxygen in indigo always takes up 12.2%, regardless of how big your sample is or how small your sample is. And in the question, the sample happens to have a total mass of 25.0 grams. Right? So knowing that it takes up 12.2%, all we have to do is take 12.2% of 25 grams, and that gives us the mass of oxygen. So then, the mass of oxygen in 25 grams of indigo is 3.05 grams. Or another way of saying this is oxygen takes up 3.05 grams in 25 grams of indigo.